Hello, welcome to goal number 10, which is multiplying and dividing rational polynomial expressions. To refresh our memories on this, let's make sure we know some of the basic rules for working with fractions. When we have multiplication taking place with fractions, we could simplify these top to bottom, or we could simplify them from diagonals. So when we look at this one, when we have 2/5 times 10/6, we can reduce them diagonally going that this is 1, this is 3, and 10 and 5 will reduce and become 1 and 2. And then remember to multiply fractions, we just go straight across, so the answer for this would be just 2/3. Okay? The important one that you need to know for this unit is the rule for division. Remember, when we're dividing fractions, we do not allow division to take place. Instead, what we do is we convert this to multiplication, and then we take the reciprocal of the fraction afterwards, which means we're going to have a 2/1. And then we multiply across, or we simplify if we can within it. So this will become a 1, this will be a 2, which means we'll end up with just 3/2 when we multiply across. Okay, so that's a quick little refresher on what we're going to be doing in this unit. But your problems are much bigger. So what we're doing in these is we're going to take and factor each one of these polynomial expressions, and we're going to be multiplying them together or dividing, depending on what the problem is, and we're going to simplify them as best we can. We're going to need to do domain restrictions too, just like we did in the previous section. So when we look at letter A here, 5x to the 5th, can't factor. It's a monomial. It's already done on its own, so we can't do anything with that. But if we take the denominator and factor that out, x squared plus 7x plus 12 is going to become x plus 4 and x plus 3. It's a trinomial with a leading coefficient of 1. Multiplied by, for the top part, x squared minus 10x minus 20, we're going to change this to an x minus 5 and an x plus 4. Again, that's a trinomial leading coefficient of 1. And then here we have a 10x cubed. Now, simplifying top to bottom. Before we do this, we have to take care of domain restrictions, and it's anytime there's a variable in the denominator, anytime at all in the problem. So here we're saying x cannot equal -4. Here x cannot equal -3. And here x cannot equal 0, because 0 cubed is 0, and then 0 times 10 is just 0. So we can't divide by 0. So now let's reduce top to bottom with these. Well, if we look, we have an x plus 4 on the bottom and on the top. We have an x minus 5 and an x plus 3. We can't cancel those. Look at these values, though. Now, think back to last section. This is a monomial. These are binomials. Binomials cannot be broken up. Monomials can be reduced with other monomials. So if we have 5 and 10, we can reduce this and make this a 1 and a 2. If we look at the x's, we have 5 x's on top, 3 on the bottom, so we can get rid of 3 here, and we're only going to have 2 remaining on top. So it gets a little messy, but you just got to keep track of what you have remaining to get your simplified answer. So we have 1 x squared, x minus 5, and then on the denominator we have x plus 3. And again, recall your domain restrictions for this were -4, -3, and 0. So this is your overall simplified answer for the problem. Okay? Gets a little messy. I'm going to try showing you another method that cleans it up just a little bit so you don't have all this kind of mess going on here trying to keep track of everything, okay? So look at letter B here. In letter B, we're going to go through and we're going to factor this all out before we change the division to multiplication. Notice we have division. Before we change it, factor it first. Okay? So in this first part, we're going to have our 8 minus k cannot be like this because it has to be in the correct form. So it's going to be -k plus 8. K squared minus 64 will become k minus 8 and k plus 8 because it's the difference of two squares. We still have divided by k minus 8 and k plus 8. Okay, now, we could factor this first one out a little further. Actually, we should. It's a -1 times k minus 8. Because we can't have that leading coefficient of 1, so we're going to basically just cross that out. Before we do any changing, we have to first determine if there are any domain restrictions, because this is a fraction and so is the rest. So we have k cannot equal 8, k cannot equal negative 8, k cannot equal negative 8. Now let's change it. So that division is going to become multiplication. We have negative 1 times k minus 8 over k minus 8 times k plus 8. Division becomes multiplication, and then we take the reciprocal, k minus 8 and k plus 8. Sorry, plus 8 and minus 8. It's a minus, sorry. All right, so now we determine, is there anything on the top and the bottom that we can get rid of? There's a lot, actually. K minus 8, we can get rid of another k minus 8 here. K plus 8, we'll get rid of another k plus 8. I can't get rid of this negative 1, and I can't get rid of this k minus 8. So we're left with, for our answer, negative 1 over k minus 8. And then let's not forget the domain restrictions, that k cannot equal 8 or negative 8. All right, let's go on to letter C. Same idea as the last ones. First try, our first one that we're going to do here. If we factor out the GCF, we end up with 3 times x plus 4. This is just a 4x. Division, let's not change it yet. We have to deal with the domain restrictions first before we can change it. What are the domain restrictions? Well, when we look at these, this x right here cannot equal 0, because then that would be 4 times 0. This x right here cannot equal 0, because then that would just be 2 times 0, which is 0. So far we have the same domain restriction. Now let's do our little switch. 3 times x plus 4 over 4x. Multiplication and reciprocal. Now, notice again, we have a fraction here. Because we have a fraction, we have to worry about the domain restrictions again. So what this means is that we have x cannot equal 0 right here, and x cannot equal negative 4 right here. So you still have to worry about those domain restrictions. Let's simplify this one. If we look at what they have on the top and the bottom, x plus 4's will cancel. The x's right here will cancel. 2 and 4 will reduce and become a 1 and a 2. We've officially eliminated everything except for that little bit that's remaining, which just happens to be a 3 over 2. And then still remember that x cannot equal 0 or negative 4. This is your completed answer. Okay? And then letter D. Let's just try one more. Hopefully this will help. For letter D, when we do this one, we have 16a to the 7th over 3b to the 5th times, because there's no factoring involved. These are all monomials, so there's no factoring. So we could just do the switch now. 6b 8a cubed. Let's not forget to talk about the domain restrictions. B cannot equal 0. B cannot equal 0. B cannot equal 0. And A cannot equal 0. That's all the denominator restrictions. And now let's just simplify top to bottom. 16 and 8 will reduce and become 2 and 1. A to the 7th and A to the 3rd, we can get rid of 3 A's, and it's going to leave me with just 4 A's on top. 6 and 3 will reduce, leaving me with just a 2 on the top. And B to the 5th, I can get rid of one of the B's, and we're going to have 4 remaining of the B's on the bottom. It's messy. Hopefully you can still see it, but what are we left with? 2a to the 4th times 2 is 4a to the 4th. On the bottom we have b to the 4th, and that is it. And don't forget our domain restrictions. A cannot equal 0, b cannot equal 0. There's our final answer. So we have just one more for practice. This is the challenge one. All right. Pause it, try it, and then check your answer. Okay, here's the worked out solution. We have 5 times x squared plus x minus 6, 10 times x plus 3, divided by 2 times x squared minus 4, 6 times x squared plus 6x plus 9. This will become 5x squared, 5x plus 3 times x minus 2. This will be 10 times x plus 3 divided by 2 times x minus 2 and x plus 2 over 6 times x plus 3 times x plus 3. Let's talk the domain restrictions here. X cannot equal negative 3, x cannot equal negative 3, and x cannot equal negative 3. Now let's do our reciprocal. So we have 5x plus 3 times x minus 2 over 10x plus 3. Multiplication, we're going to have 6x plus 3 times x plus 3. We're doing the reciprocal now. 2x minus 2 times x plus 2. Again, concern yourself with those domain restrictions. X cannot equal negative 3, x cannot equal 2, or x cannot equal negative 2. And now we can finally simplify top to bottom. We get rid of an x plus 3, an x minus 2. We can simplify the 10 and the 5, so this will become a 1 and a 2. 6 and 2 we can reduce, and this will become a 3 and a 1. It looks like that's all we can simplify, so the final answer here is going to be a 3x plus 3 times x plus 3 divided by 2x plus 2, and note your domain restrictions. X cannot equal negative 3, 2, or negative 2. Whew, that was a lot. Go back, try it again. It's a challenging one, but hopefully you guys were able to do it. Good luck and have a good day.